Angles formed by parallel lines. A quick reminder, we can name a line with capital letters. We can call it line AB, but we can also just use a single lowercase letter. Often we'll use a lowercase letter because it's kind of like a shortcut. Our first theorem is the corresponding angles postulate. Reminder, a postulate is a statement that is assumed. If two lines are parallel and crossed by a transversal, then corresponding angles are congruent. First thing you got to know here is that line N is called a transversal. Transverse means to cross. So a line that crosses other lines is a transversal. Now, the important thing to realize here, we only have corresponding angles that really mean anything to us if the two lines are parallel. When they're parallel, the corresponding angles are congruent. So which angles am I talking about? Well, angle 1 and angle 5 are corresponding angles. Angle 3 and angle 7 are corresponding angles. Angle 2 and angle 6 are corresponding angles. Angle 4 and angle 8 are corresponding angles. And if the lines are parallel, corresponding angles are congruent. Again, look at the locations. Notice how they're in the same relative positions with the parallel lines. Angle 1 and 5 are both above the parallel lines and to the right of the transversal. Angle 3 and 7 are below the parallel lines and they're to the right of the transversal. Angle 2 and angle 6 are on the left side of the transversal and both above the lines. And angle 4 and 8 are both below the lines, the parallel lines, and again on the same side of the transversal. These are called corresponding angles, and if the lines are parallel, they are congruent. Next, we have the alternate interior angles theorem. If two lines are parallel and crossed by a transversal, reminder that we usually show parallel lines are parallel by putting the same number of arrows on them. I didn't do that on the last one. If two parallel lines are crossed by a transversal, then alternate interior angles are congruent. They're on alternate sides of the transversal. They're on the interior of the parallel lines. So alternate sides of the transversal, angle 4 and angle 5, and in between on the interior of the parallel lines. I have one more set of alternate interior angles, angle 3 and angle 6. They're on alternate sides of the transversal and again on the interior of the parallel lines. So angle 3 and angle 6 are alternate interior angles, and angle 4 and angle 5. Listen to the way it's named, alternate sides of the transversal on the interior of the parallel lines. Next, we have the alternate exterior angles theorem. Reminder, a theorem is proved, unlike a postulate, which is assumed. If two lines are parallel and crossed by a transversal, that's line N again, then alternate exterior angles are congruent. They're on alternate sides of the transversal and on the exterior of the parallel lines. So angle 2 and angle 7 are alternate exterior. Angle 1 and angle 8 are alternate exterior. So angle 1 is congruent to angle 8 because they're alternate exterior, alternate sides outside the parallel lines, and angle 2 is congruent to angle 7 because they're alternate exterior, alternate sides of the transversal on the exterior of the parallel lines. Here's the number one spot that students flub up. These are called same side interior angles. The same side interior angle theorem says if two lines are parallel and crossed by a transversal, then same side interior angles are supplementary, not congruent. All the others, alternate interior, alternate exterior, and corresponding, are congruent. These are not congruent. They're supplementary, meaning they add to 180. So look at the way they're named. Same side interior. They're on the same side of the transversal and on the interior the parallel lines. So angle 3 and angle 5, not congruent. I'm just showing you where they are same side interior. And angle 4 and angle 6 are same side interior. You've got to keep it straight. These are not congruent. They add to 180 degrees. Same side interior angles add to 180 degrees. They're always supplementary if the lines are parallel. Let's take that diagram and just put in some numbers so you can see it all. Remember that the lines are parallel. I'm going to make up numbers here, just one number. Let's say that angle 1 is 60 degrees. If angle 1 is 60 degrees, we know that from here to here is they're a linear pair, it's 180 degrees. So this one would be 120 degrees because 120 and 60 make 180. Well, you can repeat that again this way. Angle 2 and 4 are a linear pair. So angle 4 would also be 60 degrees because 120 and 60 make 180. And then if you haven't observed, I didn't really need to do that, these are vertical angles. So that I could go the other direction and have vertical angles. That means angle 3 is 120 degrees. Back to our theorems, we know that corresponding angles are congruent. Corresponding angles are like angle 2 and angle 6. So those two are congruent. That means angle 6 is 120 degrees. Angle 6 and angle 5 are a linear pair, so angle 5 would have to be 60 degrees because those two make a straight line. And 6 and 7 are vertical angles, so 7 is 120 degrees. 5 and 8 are vertical angles, so 8 would be 60 degrees also. Now, look at those numbers and notice the pattern. Picking one pair of each type, we see that angle 4 and angle 8, those are corresponding angles. They're both 60. We see that angle 6 and angle 3, they're alternate interior angles, and they're congruent, 120 and 120. We see that angle 1 and angle 8 are alternate exterior angles. They're both 60. They're congruent. And same side interior angles are supplementary, not congruent. So picking a pair here, we could say that the 120, angle 3, and the 60, those two, angle 3 and angle 5, are supplementary. They're same side interior, and they add to 180. Here are some questions from your assignment. Looking at the parallel lines and looking at this transversal, we see the 75 and the Y are alternate interior angles. They're on alternate sides of that transversal, I marked in blue. They're on the interior of the parallel lines. That tells us that Y has got to be 75 degrees. Looking at the other transversal, which I'll mark in red, we see that the 51 and this angle right here with nothing on it are alternate interior angles. They're congruent. So this angle would also be 51 degrees. Now I know that from here to here is 180 degrees. So I'm going to have to take 180 degrees and subtract off the 51 degrees and subtract off the 75 degrees, and that's going to give me x, whatever x is in degrees. 180 minus 51 minus 75 ends up being 54. So x here has got to be 54 degrees to make those three add to 180. 54 degrees is our answer for x. Here we have some questions where we're going to set up an equation and solve for x. And once we find x, we're going to plug it back in to find the angle. Now, be aware that the angle you're looking for might be somewhere else in the diagram. Depends on the question. It's random. Well, this angle and this angle are alternate exterior, so they're congruent. That means that 4x plus 120 would have to equal negative 9x plus 211. So we'll add 9x to both sides, and 9 plus 4 is 13x. We'll subtract 120 from each side, and 211 minus 120 is 91. And we'll divide both sides by 13, and 91 divided by 13 is 7. So now we can actually find the angle. This angle would be 4 times 7 plus 120. So that's 28 plus 120, which is 148. So 148 degrees is what we got there. Well, let's just look around the diagram here. We know that 148 plus the angle right here, where that A is, would be 180. So that's 32 degrees. This is a vertical angle. It's 32 degrees. This is a vertical angle. It's 148 degrees. This is a corresponding angle with the 148. It's 148 degrees. Notice again that there's the alternate interior, 148 and 148. So this one, in fact, is 32 degrees. These are vertical angles. That's 32, and that's 148. So x was 7. Angle TCA, let's change colors. TCA is 148 degrees. In this example, we have corresponding angles. And again, we know that corresponding angles are congruent. So 6x plus 55 is 2x plus 99. That's 4x plus 55 is equal to 99. So 4x will equal some negative number. 99 minus 55 is 44. And x then is 11. Now we'll plug that in. How about down here? 2 times 11 plus 99. You can plug it in either one. It does not matter. So that's 22 plus 99, which is 121 degrees. Well, this is 121 degrees. It's a vertical angle. 180 minus 121 is 59. So these two are 59 degrees. This is an alternate interior angle. It's 59. This is an alternate interior angle. It's 121. This is a vertical angle. It's 59 degrees. And this is 121 degrees. So x is 11. And angle YDA, YDA is 121 degrees. Here we have a pair of alternate interior angles, and alternate interior angles are congruent. So 9x plus 148 is equal to 12x plus 151. How about we subtract 9x from each side, and this becomes 3x. And we'll take off 151. So 3x is equal to negative 3, and we'll divide by 3, and x is negative 1. Now we'll plug that in, and we get 12 times negative 1 plus 151. So that's negative 12 plus 151, which is 139 degrees. So this is 139 degrees. It's a vertical angle. 180 minus 139 would be 41. So these two are 41. They're vertical angles. This is 41. It's an alternate interior angle. This is 139. It's an alternate interior angle. And there's my 139 vertical angle and 41 vertical angle. So x is negative 1. And the measure of LDY, is 139 degrees. Last example, and this is the one that trips students up because same side interior angles are not congruent. They add to 180. So this angle and this angle are not congruent. They're on the same side of the transversal on the interior of the parallel lines. They add to 180. So 8x plus 26 plus 7x plus 94 is equal to 180. That's 15x plus 120. That 26 plus 94, I'm simplifying, is 120 equals 180. I'll subtract 120 from both sides, and 15x will equal 60. And I'll divide by both sides by 15, and I get x is 4. So plugging that in right here, I get 8 times 4 plus 26. And 8 times 4 is 32. And 32 plus 26 is 58. So this angle is 58 degrees. This angle is 58 degrees. And if I subtract from 180, I get 122. So I've got two vertical angles that are 122. Alternate interior angles, this is 122. Alternate interior angles, this is 58. Vertical angles, I got a 58 there and a 122 there. So x is 4. And WCX is 122.